Got it. Hello, everyone. We are really glad to see you here and that these events that we are creating with CIPA, you can see our team and our experts. We are having background, so you can identify us. Our basic team is Michelle, Nefeli, Renata, and Anna. And today, Joe and Hélder will present, and Chloe at in the end, and we are waiting another expert. So today I want to present you our presenter and why we are here to hear his research. And that is Hongchao Liu. He comes from Beijing University of Civil Engineering and Architecture. He's dedicated to disaster prevention, disease detection, conservation, research and repair, and reinforcement of wooden and stone heritage buildings. He was conducted numerous cultural heritage conservation studies at the Angkor Wat in Cambodia, the Wooden Pagoda in Yingxian and Shaanxi, and in the Forbidden City in Beijing. So I think today we're going to hear a very interesting I think we lost him for a moment, but he will share his presentation. And Hongchao, the floor is yours. You have 25 minutes. So just keep your time and we are here to listen to you. And after you're going to receive comments and we are going to have discussion. The floor is yours.
I think I need to make him co-host again. 1 second. Great.
Okay, hello everyone. Hello everyone, I'm Hongchao from Beijing University of Civil Engineering and Architecture. In the past 6 years, I have been carried out the study of architectural heritage conservation. And at the same time, in the process of study, I have carried out a lot of practice of architectural conservation and engineering projects. Today's topic on my presentation methods for appearance damage in timber components of critical buildings based on portable LiDAR equipment. Combining with my Euro work experience, I will introduce the idea and the progress of the recent research, as well as the prospect of the follow-up on this basis. The outline of my talk as follows. The first part, I want to introduce the background and the significance of the research content. The second part is the result and application of the research, and then followed by some ideas about the research content to compare the research direction. First of all, among the existing ancient architectural heritage in China, frame ancient buildings have a very large number and copy at the same time. This type of the architectural heritage is also extremely vulnerable to damage. Therefore, the existing related researchers are concerned on detecting and preventing the damage of wooden structures. Various technical means have been popularized and used in a survey and detection of wood frame Asian buildings. But how to detect and identify these wooden components in a timely and accurate manner is still an unsolved key problems. Existing detecting technology in the further damage detection has certain limitations. Manual measurements using a tape measure and other tools as far as possible to obtain a set of data records, or simply take pictures, low precisions, retracted area, less information, ultrasonic, straws matter in impedance matter mainly for internal damage detection. While some qualitative measurement of the components, high cost, high technology requirements, long cycle time, poor timelessness, existing LiDAR measurement methods include stationary arrow, and the main measurement object is often the building as a whole or frame, which is not applicable to the components with high cost, complex processing, and poor operating photogrammetry. Low precision and complex processing. 2020, there began to be personal smart devices embedded in LiDAR sensors, making it possible to try them out in various specialist fields. So with the help of my own daily use, I will also try it on the superficial inspection of timber components. Based on this situation, in order to compose the apparent traces of damage left in the timber components of Asian building as comprehensively and realistically and as possible to preserve the value information of each stage, I propose a portable LiDAR equipment-based precision detection and identification methods for apparent damage of timber components in Asian buildings. In the system components and the working principle part, handheld LiDAR scanning devices such as industry-grade scanners or built-in laser sensors, only cell phones and tablets PCs are used to model the timber components in Asian buildings in detail. Compared with the existing Chinese Asian building timber components inspection system, it has the following technology characters. First, flexible and portable, easy to detect. The small size of the device can be measured flexible in a small space without damage. Components and even avoid the handle possibility of injury to the surroundings during multiple measurements. Secondly, is the completion of the laser scanning and photogrammetry synchronously. This is similar to the handheld LiDAR scanner, but in the cost of the equipment wall and the need for data pre-processing part of the advantage. Third, the arithmetic power empowers the intelligent processing of the raw data. With the high performance built-in chips and the application, it is possible to realize data pre-processing, reducing the workload and also have a less tree and your time and cost. The key elements of data acquisition are basically similar to those of the established photogrammetry, although more attention has been paid to scanning of the point cloud and the scope of the acquisition. The outstanding advantage of the data pre-processing under the standard procedure is that the work of crude model generation is completed at the same time of acquisition, which saves a lot of post-processing work. On this, basically, I propose two methods for secondary processing and analysis based on the captured data illustration, which are the 2-bit unfolding illustration and the sectionary illustration methods for 3D data of timber components. On the basis of the model that completes the data processing, precision methods measurement analysis can be carried out. As in conventional measurement, the measurement of the geometric feature of the components can be carried out based on the precision triangular mesh model generated from point cloud data. Comparison were made with the result of conventional measurement to meet the accuracy requirements for the 5 details of Asian buildings components under the highest first classes accuracy in the relevant specifications. The sectional graphical methods allows the analysis of cross sections of table components in multiple sections, and the statistical analysis of the depth and area of cracking and the changes in the cross-sectional area of the components that it captures. As a way to allow for the distribution and the development trade of apparent damage, such as cracking, to be judged. However, the accuracy of its part is insufficient, especially for deeper internal damage, and other measurement methods need to be coordinated. After obtaining a digital model of timber components, is it possible to perform tests in the computer that cannot be done with real components? I think it's possible to visualize and calculate the cross-section of components by sectioning the 3D data of the components. In the calculation of load carrying capacity of structural components for the main compression and the bending components after the damage of the timber components, the remaining area and geometric properties of the most dangerous cross-section of the components need to be calculated and verified to determine whether their strength and stability meet to the requirements. In turn, the residual bringing capacity of timber components in just to achieve the purpose of long-term health monitoring of damaged timber components. Therefore, I conducted an investigation on the geometric characteristics and load capacity assessment method of irregular cross-section of components. The main content is divided into several parts. The first is to carry out the acquisition of the apparent information of timber components. On the basis of obtained 3D data of timber components, the data model is uniformly sliced to obtain the overall cross-section variety of the components. Then I use the alpha shape to automatically extract the cross-section profile of the obtained slice of timber components and calculate the geometric properties of the irregular cross-section based on the slice profile. There are two innovations. First, the data acquisition method. The portable LiDAR equipment used specifically for timber components for data acquisition, fast and efficient, less noise redundancy, high reconstruction accuracy, suitable for data dissection and further analysis and investigation. For the acquisition of the cross-section geometric properties, after sliding the point cloud data of timber components, individual slices are projected onto a 2D plan, and the slice counters are extracted by using the alpha shape algorithm in server, which transforms the accurate counter into a series of 2D point data. Using the Grace integral algorithm, the area and the geometric properties of the cross-section shape can be quickly derived by performance and the integration operation on the boundary points of the irregular counter. with the geometric properties and the loads of the cross-section, as well as the timber matrix properties, the load carrying capacity of the components can be checked. In order to compare the different methods for defining timber components cross-section in existing investigations, 8 ancient actual timber columns were used, and 15 millimeters 6'4" cross-section specimen was cut in the middle of each of the columns and scanned at the high resolution. And the scanned images of the cross-section were imported into AutoCAD to obtain the real contours of the components cross-sections. At the same time, different cross-sections acquisition methods were tested. It is found that the more realistic and technical can reflect the correct morphology, the better its performance in terms of the accuracy of the cross-section measurement. Among them, portable LiDAR devices can be scanned close to cracks in a handle way, and the internal data of the cracks are more clearly acquired, which in turn achieves the effect of the data closer to the real cross-section. In addition, the relationship between crack width and accuracy is analyzed through linear regression, and it is found that the larger the width of the cracks, the easier it is to detect the inside of the crack, and the final data obtained is more accurate. The above judgment is also verified. In addition, I propose correct analysis methods for timber components under 2D unfolding illustration. Traditionally, correcting judgments are made by observation and local measurement, and the curvature and discontinuity of the component's surface can lead to an incomparable judgment of the cracking characters and developing trait. Through the 2D unfolding of the digital model of timber components, the apparent damage area and the size of the components can be clearly measured and analyzed. The measurement of the apparent density can and the distribution of wood knots can be digital marked and analysis. Combined with the microtrace analysis methods is archaeological investigation. The apparent microtrace remains of components can be identified and marked, and combined with the structural character of the buildings. More research on the history of the building can be achieved. After achieving digital identification of surface damage of timber components, intelligent automated identification became the next step. I tried to use the deep learning method to automatically perform recognition on the acquired components data. ULV-N in the deep learning was used as the base model, and 866 images of correct timber components were used as the data set for model training. In this way, the automatic identification of different type of damage on the appearance of timber components was achieved. Through the experiment, it can be seen that my proposed surface damage detection algorithm, ULV-N, is optimal in terms of MAP, number of model parameters, and model computation. Compared with ULV-N, the MAP is improved by 1.8%. The number of model parameters is reduced by 1.05 m, and the amount of the model computation is reduced from 8.1 G-flops to 6 G-flops. On the basis of the above, I have carried out a lot of practice work in conjunction with energetic projections in Datong City, Shanxi province for the ancient wooden buildings on the verge of collapse. I have carried out a lot of modeling work of digital twins of wooden members for marking the protecting the members in a local 8 years old Asian theater. I analyzed the damage of the wooden components and provided a long-term monitoring data report. For the famous Asian building Chongshan Temple, I combined the damage detection of the members into analysis of the overall wooden frame to judge the structural stability of the whole buildings. That brings me to the end of my presentation. I'm still experimenting with new approach in the conservation of ancient buildings in timber. So if you are interested in my work or would like to come to Beijing, China, and the surroundings areas to working on ancient building conservation, please feel free to contact me. I'm very glad to be here today to share my thoughts with all for you. Thank you. That's all.
Thank you very much for your presentation. I'm going to give the word first to Renata and Nefeli, so they can present our experts. And thank you very much, Hongchao. It was very interesting and very clear. So now I think you're going to receive very valuable feedback.
Thank you, Dina, and thank you, Hongchao, for sharing your presentation with us. So we will introduce each one of the experts that will have some comments today. So first, Alex Yan is a full professor of the Department of Architecture at the China University of Technology in Taiwan. He was the vice president of CIPA Heritage Documentation and currently our contact for ICOMOS on the executive committee. Alex majored in the history of architecture, conservation theory, and implementation, and has more than 40 years of experience in this field. We will also have comments from our expert, Joe Kallas. He's an architect and cultural heritage specialist with significant experience in disaster response and reconnaissance missions. As an expert CIPA member, he uses digital technology to support recovery efforts in post-disaster areas. Also serving as a UNESCO international expert, Joey contributes to heritage preservation in disaster-affected areas such as Beirut, Ukraine, and Syria. He's currently a PhD candidate at Penn State University, where he focuses on integrating artificial intelligence and machine learning with 3D structural assessments to improve disasters reconnaissance and enhance building resilience. Thank you for being here today, Joey and Alex.
And also, I would like to present the two other experts that we have today. So, first of all, Hélder Sousa is a researcher of the School of Engineering of the University of Minho in Portugal. He made his doctorate thesis in 2013 about methodologies for safety evaluation of existing timber elements. His research domains include safety assessment of timber structures through non-destructive methods, with special emphasis in visual inspection and through reliability analysis by probabilistic methods. He makes a permanent team of professionals on the BEAM A+ European Master. And also, I would like to introduce Chloe Pei. She's a digital heritage expert specializing in applying contemporary digital technology to cultural heritage conservation and interpretation, currently serving as the creative director of the Tissue Heritage Institute of Digitalization. Her work spans historical research, interpretation, and presentation, as well as sustainable utilization and operation. Since 2023, she has also served as Deputy Secretary General of the ICOMOS China Scientific Committee of Cultural Heritage Conservation by Digitalization, focusing on international exchanges and cooperation. We are really looking forward to your remarks. Thank you, everyone. I think we can start with our first expert, Alex Yen.
Okay. Can you hear me? Yes. Okay. Good morning, good afternoon, and good evening, everybody. A greeting from Taiwan. I apologize that due to some technical reasons, so I suppose that's 5 minutes late, so I cannot listen the full presentation of the Mr. Liu, but I already read his abstract and most part of his presentation. First of all, I have to say that I didn't expect there are more than 20 colleagues and young professionals that joined this meeting. I think it's very, very interesting and the very important event for not only the participant but also for the CIPA. So many young generation young blood can refute the CIPA. It's very important. And one information for you, I'm no more the vice president of CIPA since 2024. I have already served for 6 years vice president, and now I'm a member of executive committee. So it doesn't matter. And I think there are so many participants, so I will make my comment very short. First, I have to congratulate that Mr. Liu had done a lot of works and also a very interesting presentation. And I'm not very clear that I suppose this presentation is a report or a comparison study, and the main purposes is not so clear. You want to make a comparison for the portable instrument, portable LiDAR or portable iPhone can do better than the normal LiDAR scanner or the photogrammetry, or you want to express the portable LiDAR can do a lot, not only the accuracy, but also can do many acquisition, data acquisition, and the help the analysis. What is the main purposes? And in my idea that the way we do the documentation or we do the survey is to help the conservation. So what is the difference with the portable iPhone and the normal general LiDAR scanning? What's the difference? Cheaper, faster, or what? The accuracy or what? I'm not very sure if you understand my questions. And I did a little bit homework yesterday and today. I found there are two papers. They already studied the accuracy for the portable iPhone 13. Of course, now it's 15 already. So the accuracy is already they have done a lot of research over there. And what's difference in your research? And as to the object you survey for the deterioration of the timber object, and you mentioned through your survey you can find the detail of the cross sections deterioration of the wood. It's very interesting. And are there any different difficulty for the general LiDAR scanning, or it's the same? What's difference? I think if you can do a very much better, maybe I didn't listen very carefully. If you can reorganize your paper and make a very good comparison to show, even though we use a very small scanner like iPhone, and we can do much better, much easier than an expensive LiDAR scanning. It will be much better to support your conclusion. And anyhow, I have to congratulate you. Did a lot. Thank you.
Thank you for question. In our normal project, when we work on the conservation projects in Shanxi, when we found the Asian buildings components have cracked, like a cracked, we need to use ruler to text the width of the crack, the deep of the cracks. And finally, when we finish this project, we need to give a report to government. So right now, we only can give a report only with some data by pen right down. But if we can use iPhone, some 怎么说we can provide more digital reporter and for more better models and digital record and to as a digital twins to save in internet. Maybe we can 1 year we can test one test, so we can save the many digital records, help us to find the growing of the cracks in the timber components. It's cheaper. I don't know how to say, but it's a useful work for report. That's sorry.
Yes, I can understand what you like to do, but I have to. It will be much more convenient and much easier to much better to use manual documentation. However, my question is, besides the iPhone, you have traditional scanner. Otherwise, you have photogrammetry method also can get very high accuracy and also very easy, very convenient. So in your paper, I suggest you may try to make some comparison study and also citing some already existed paper to help you to convince to establish, to set up some basic rule or guideline for the site surveyors to do some research or documentation. It will be much better for your for their works. Will be much more better to reinforce your presentation.
Alex, thanks so much for your comments. We'll move to Joe. Joe, less than 5 minutes, please. And then we'll go to Hélder and Chloe. Hongchao, if you can just hold off your response until the 3 experts speak, that would be great. So just make some notes. Go ahead, Joe.
Yeah, so thank you, Hongchao. So your findings offer a promising direction for the field of historic preservation, suggesting that digital transformation in this area can lead to safer, more affordable, and efficient methodologies. So continuing to explore the limitations and potential improvements to this technology will be key to its success. However, it might be useful to delve deeper into specific challenges faced during this integration process in your future presentation. So I just have two quick questions for you. So what are the main limitations you've encountered using portable LiDAR technology for damage detection in historic timber buildings, and how did you address these challenges? And the last one is, could you elaborate on the techniques used for the graphical interpretation of LiDAR data? How do you ensure the accuracy of damage identification from the data collected? Because usually we have the predicted damage and the ground truths, and we compare the both to get a scientific percentage of how accurate the damage detection was. I saw you talk about automatic damage detection, but I believe you were comparing the LiDAR detection to the image, segmentation thing. But I was not sure how you were getting the accuracy from the LiDAR damage detection. So that's for me. Thanks.
Thanks, Joe. Chloe, sorry, Hélder, go ahead.
Yes. First of all, very well presented, Hongchao. I think this is a very interesting topic and has been dealt with several researchers on this procedure. I just want to, let's say, make two main comments. One of them is related to the material itself. So we can do the same analysis if we're talking about timber, stone, concrete, and other materials, but timber is quite special in this case due to its, let's say, natural characteristics and properties. Having a crack along the fiber alignment is not the same of having a crack perpendicular to the grain. So that's something that you have to take into account when doing something that it's too much automated in the process. Be aware of the material itself. Another thing also related to cracks is it is quite important to understand if with your method a crack depth is very well detected in terms of its width. So how much can we actually see within the crack, taking into account the width? Because sometimes, and this is also material related, very thin cracks that almost do not allow us to see inside are the critical ones, depending on where they are and their direction. So be careful with that on your analysis. Another thing, just to make a comparison, is if you have a knot. A knot in a compression side of a timber element may not be very problematic. A knot in the tension side of an element in a timber structure may be quite problematic. So be aware also that this automatic procedure must always be somehow calibrated with other analysis. And just to finalize the first area of discussion is, unfortunately, the major problems on timber structures are the hidden ones. So when we are talking about internal decay and when we are talking about the connections, what we don't see is actually a problem. So there are several researchers that are actually combining laser scanner and techniques similar to those with other non-destructive tests. You showed drilling resistant measurements. You can somehow try to combine this, and this is a way to go. So take a look on that. The second area, and going a bit aside from timber structures, is digitalization. You mentioned digital twins. I think you said it in your presentation that you are doing a monitoring system, a long-term one. That is very important because unfortunately, or fortunately, digital twins is a buzzword, but sometimes people tackle it like it was a three-dimensional model, which is not. You have to have also the 3D model, of course, but you have also the need for sensoring. So monitoring in order to have what is the behavior of the structure on that moment, or even predicting in the future, taking into account your digital twin. So always combine this information, and this is where your digital model can be also very strong, is archiving all of this information from non-destructive tests, historical surveys, in visual inspections on your model, and afterwards have more information with that, but always have 3D model and information, sensoring, monitoring, archive information, data information on that. But those were small comments to think to have a better work on very well already organized and presented work. Congratulations.
Thank you very much for your feedback for this presentation. And I'd like to ask to Dr. Chloe Pei, please, to give her thoughts about the presentation, please.
Thank you.
And also to the people that have raised their hands in the audience, please, let's just wait for this discussion to end. And then at the end of everything, there will be the question and answer time. Thank you.
Thank you. And I also have to extend my congratulations to very fruitful results, and also to all the experts who already given the comments. I fully agree and share a lot of the sentiments that you have sent already. And just to add a little bit on top of what's already been said, and I fully agree with Alex that a clear intent of why the research is conducted or the work is conducted is very, very important. And we have seen a lot of tests, and then a lot of try and error has been done. And then we see a lot of work has been done. But why we are conducting this work is very important. And when you answering Alex's questions, and I heard that you mentioned that throughout the field work, the actual field work in China, and then it is done by ruler, and then you need to provide the report to the government. And I think that we need to be conscious why the traditional method is used. It is because the well, I will say the sustainability of expertise, because I will have to say that the digitization is not as well publicized or as well promoted in the actual working field. So the digital expertise may be very, very rare in the actual working field. And when you actually mention that you need long-term monitoring, that means that you actually need the experts, the continual experts that understand the previous data, that also have the ability to keep on the same research over the long time to make sure that this set of data is being kept. And it's not, as we know that for a lot of the digitization work, it actually generates a lot of obsolete data that may become inaccessible in a couple of years, not really like in a couple of months even. And if you're moving a new team to the same projects, and they may not understand the data previously, so we also need to consider the data operability if we actually talking about the very specific working field. So as some also as practitioners in China, I think this is where I'm coming from, is that when we're tackling the actual field, then there's a very vital aspect that we need to consider is how do we transmit those digital assets and digital expertise to the ongoing working process? How do we make sure that those data can be sustainable in a way? So if that is actually your goal, and if you really wanted to propose this to be a new methodology that to be promoted throughout the workspace, then I think it's very important that you continue your research, but also provide a feasible way to see that how are we going to actually carry this out in the long term, or like in phases, how are we going to transmit those knowledge and expertise to users that may not understand this properly, say the stakeholders himself, even though we're providing a really thorough report. But the problem will be that if they do not read the graphs, or they do not understand all the calculations or the deep learning behind it, then it still not be able to make the decision. So basically the data that we provided, it has to help to making the final decisions, or to help to aid those decision-making process for the conservation. So I think it just perhaps it's a next step when you start to compiling more data, and then when you start to having what we call the pipeline or the workflow, then start to thinking about how do we make those actually sustainable in the workplace, it will be very important. But nevertheless, congratulations on all the work that you did so far. And we're really looking forward to the next development of your research. Thank you.
Thank you for pointing that out. And I will try my best to amend it in my later work. Yeah, thank you.
Hongchao, do you have something else to add related to the comments that you have been given by the experts present here? Do you want to reply to?
Many questions, but maybe I can't answer tonight. So only I can do is try my best to amend it in my later work. Yeah. Sorry.
Perfect. So I will give the floor to the question and answers time. So if there is anyone from the audience that has some curiosities or any kind of answer that can be asked to our Hongchao, now it's your turn to raise your hand and speak. Thank you.
Maria, if you're still there. Yeah, okay, go. Hi, Maria, it's good to see you. Oh, I'm sorry, you can unmute yourself or?
Yeah.
Great.
Okay, first of all, thank you very much. It corresponds really very with our actual project at University of Bamberg in Germany for estimation of timber stability by automatic recognition of knots. That's why I have some maybe notations to this project. First of all, about cracks. That's right. It was a little bit discussion from that what said Hélder Sousa, especially to the cracks. Depth of the cracks is really very important in this case. It's a first, and that's why sometimes we have some internal cracks which we cannot see from outside. Yes, it's a really big problem, especially for inbuilt construction. I would say there's no really optical methods, or for example, something like tomography, which goes, yes, with X-ray. That's why it's maybe can be very interesting for you research at University Bamberg about knots and cracks, which in this research, the results were that some knots, especially its size related to the timber, is important and can be as evidence for timber stability. That's why the researchers on our university made a lot of different investigations with drilling, with sonography, and so on. And the results of just visual knot detection was good as drilling, for example. That's why it may be interesting for you that you are concentrating on knot detection, for example, first of all. Yeah. Another point which I want to say, not only the depth is important, also the position and the timber, for example, the angle related to the border of the timber or to the sample of tree ring. Yeah, these two moments, I would say, they're especially important for this stability system. That's why if you want to recognize cracks, yes, you should recognize also its position and the position, for example, of tree rings, or its position relatively to the border of the timber. Yeah. To the data acquisition method, you said it was with handheld scanners, right? But if I think about big roof construction, they are really so big, and in most cases they are not good accessible for equipment. Have you thought more about photogrammetric models or some other methods for like videos or like, yeah, I don't know, for a 3D model?
Yeah, it's a good question, but I have no answer at this moment.
Yeah.
Are there
Maria?
any other questions for Hongchao? But in any case, thank you for the very interesting. I think that
Can I
all
say
the
something?
Sorry, yes.
Yes. Some idea for Mr. Liu, Hongzhou, that maybe through the discussion, is it possible for you to separate it, to cut your presentation into 4 different papers? First, a comparison study for the accuracy or what for the portable laser scanning with the traditional scanner and the photogrammetry, the comparison. And second, you use the LiDAR or laser scanning to survey the width and the depths of the wooden timber and the accuracy of the efficiency. The second. The third, how to use this kind of equipment to do the monitoring of the wooden timbers or wooden structure. Maybe in addition, the fourth is the something connect with the structural behavior of the crack, how the crack, the depth and width, the crack of the wooden timber influence the structure of the wooden monument. Maybe it's the fourth, but I suppose the fourth issues is nothing concerned with the main issues of CIPA concern. However, CIPA can support the structure engineer to do this, but some maybe 1 to 3 is big enough to be 3 important studies. But today you try to integrate all together. It's a little bit confused. So maybe try next time. Thank you. Yes, try to
Thank you.
Next step. Yes.
Thank you. Yeah, compare the different technology for the scan. Maybe it's the next step for my work. Thank you.
Someone else from the audience that have some curiosity or questions for Hongchao? Don't be shy. In the meantime, Hongchao, I just wanted to say that I believe that the feedbacks provided by the expert present here and also by someone from the audience were precious for you and for your future works, because the experts believe that your work is very interesting, but they also provided you with very precious advices for your future work. So I think that this occasion was extremely useful also for you to have to share your projects and your idea with an audience of people that are extremely expert and that have a very big knowledge in this field. So I believe that this is important for you. And thank you for your presentation and congratulations for your work.
Yeah, that was great, Hongchao. Thank you so much, and thanks to all the experts. We just wanted to also take this chance, Chloe, to tell you about the upcoming CHCD.
Perfect. Thank you, everyone. Thank you for giving us this opportunity. Just want to let you guys know that the CHCD, which is also a symposium, an international symposium that's dedicated to the cultural heritage conservation by digitizations. We are actually running side by side with CIPA So CIPA is running on every odd year, and it's biannual conference. And for CHCD, we're running on every even year. So on the even year, you will have the opportunity to join CHCD. And this is the year that's after the pandemic, we will be again face by face enjoying each other's companies in persons, offline in Beijing. So during the summer times in July 16 to 19th, it will be the year for this CHCD. We already opened the call for paper, and we also opened the call for best practice and case studies. And we will also update that link into the EPs groups so you guys can see it. So aside from contributing into the papers, you can also propose your best practice case for a case scenario that's we're entering the pool for international competitions. So those are very interesting activities. And for this particular conference, we will also have a special section that's dedicated to the EPs, which we will be having more talks later with the groups to organizing how do we want to have the EP to be. And also wanted to announce that more exciting news will coming up a little bit later. And to complementary on this particular event, we will continue our tradition for hosting international panels, which is each nations organizing in the nations unions and bring the best expertise from their particular nations. And so far, we're already pinned down Korean, Canada, Netherlands, and Italy, and with furthermore that's still going on. So at the end, we will be able to see more international panels. So I hope to see you guys all in the summers, and we really, if you cannot make it in person, we also want to see your work here so that we can see a lot of your contributions, and looking forward to everyone's. Thank you for these opportunities.
Thank you.
Thank you, Chloe,
And
very
please,
much.
Dr. Liu, come to join us since we're already in Beijing.
Thank you, Chloe, very much. It looks wonderful, and I hope that we will have opportunity to meet each other in person.
Yes, once again.
Celebrate all this effort finally together live. Thank you very much, everyone. I think we are until the end. If nobody else has additional comments, I think Hongchao received lots of interesting thoughts and ideas where his work can go. As Alex said, it can be very confusing because you heard different experts from different fields, but also this can be a very rewarding, having different views where your research can go. So it's up to you, and I hope we can see each other again, and you're going to let us know of your upgrade of your work. And thank you very much. This presentation has been recorded. We are going to upload it on YouTube. Hongchao probably is going to be interesting for you listening again, the comments. So I hope in a week time it's going to be available. And I hope we see each other on the next event.
Thank you, everybody.
Thank you. Bye-bye. Thank you very much.
Bye-bye. Thank you.
Thank you and bye-bye.
Thank you, everyone. Good night.